Hello everyone, you're welcome back to my channel. In today's video, I'm going to be showing the most interesting thing that you ever would hear about in Jamb. As you can see that we have just only 4 days to go to Jamb, but we notice that many students are kind of furious on how can I pass Jamb. So that's what brought me today to do this video for you on how to tackle questions in Jamb. Now, on a yearly basis, we believe that JAMB sets some question that's kind of twisting the brain of the students. Now, they say there are some questions in which they have like 3 to 2 answers, sorry, 2 to 3 answers. But many students does not know how to choose this. They intending to choose the right answer, but in the long run, they choose the wrong answer. So today's video, I'm going to be giving you JAMB most 10 misleading chemistry questions. But in this case here, I'm going to be doing it in what topic specific. Now, I brought you 10 questions under nature of matters. Now, here we'll be looking at JAMB most 10 misleading chemistry questions on nature of matter that are most likely to repeat for this same year, JAMB 2022. Now, if you are new to my channel, please don't forget to subscribe to my channel and click on the notification bell to receive any new notification whenever I release my video. And also, don't forget, try to comment on my videos. I'll be waiting right here for your comment. Thank you. Let's get started. Now, today I'll be taking you through each of these questions from question 1 to question 10. Please stay to the end of this video so that you can see the what's most interesting thing in this. Now let's start with question 1. Now, the first question in this is found under this question. We have the passage of sulfur 4 oxide gas into water leads to what? Now, if you see this question that you're seeing here, normally when sulfur 4 oxide gas is passed into water, we notice that it can give us two things. Number one, the passage of sulfur 4 oxide gas into water is an exothermic reaction. The reaction is exothermic in nature. But in this question here, you will notice that in the option, they are given exothermic changes, physical change, chemical change, and reversible change. What Jamb is asking from you here is not all about exothermic changes. Why? If you notice, everything is all about changes. If they are to ask maybe the reaction is exothermic or endothermic, they are going to say reaction. But here, they are only asking you about is this kind of reaction here, is it a chemical change or a physical change? That is the major thing they are asking you here. Now, if you can check here now, passage of sulfur 4 oxide gas into water leads to what? A chemical change. Because sulfur oxide is going to react with water to produce an acid. Are we together? That is the first question. Now let's jump to question 2. The second question in this is also this. Graphite is used as a lubricant because why do we use graphite as a lubricant? If you check all the options that is given to us here, question 1, option A, sorry, they said it has a sliding layer structure. Option B, it has a mobile free electron. Option C is an allotrope of carbon. Option D has no free electron. If you take a look into this question very well. Now, all these things given to us here are properties of carbon, of graphite, except from it has free mobile electrons. Now, graphite does not contain any free mobile electron, which is option B, which is there. Option C, he said, is an allotrope of carbon. We believe that carbon has 3 allotropes. The first allotrope of carbon is graphite. The second allotrope is diamond, and the third allotrope is amorphous. Under this amorphous, that's why you can have your lamp black, your lamp black carbon, your charcoal is found under this. Now, but what they are asking us here is that why is it that graphite is used as a lubricant? Any substance that can be used as a lubricant, the molecules of the substance must have the ability to slide across each other. Now, the reason why we make use of graphite is because graphite has a sliding layer structure. That is why. It is not because it is an allotrope of carbon. You know that it's an allotrope of carbon, but the reason why it is used as lubricant is because of the sliding layer structure that is found in graphite? That is the question 2. Now let's move on to question 3. This is another question that is here. It said, what do allotropes have in common? You see, many students on seeing this, they tend to fail this question. How do they fail it? Now, if you check here, we have the melting point, solubility, chemical reactions, state of matter. Now, among the 4 options given to you here, 3 of the options is the physical properties of allotropes. Now, let's take carbon as an example. Now, we know that carbon, both graphite and diamond, they are both allotropes of carbon. But one thing about them is that they differ in physical property. But one thing that they have in common is chemical properties. All allotropes have the same chemical property, but their physical properties are what different. Now, diamond is an hard structure, is an hard substance, while graphite is a soft solid. Now, graphite can conduct electricity, while diamond does not conduct electricity. These are what, like, discrepancy that is formed between the physical state of diamond and the physical state of graphite. Now, if you can check this question here, what do they have in common? All allotropes must have only chemical reaction in common. They don't have anything in common with our physical state. Their physical state is entirely different. Take note of this. In case you see this kind of question like this, you'll be able to tackle it. Now, next question there is all about alloys. Now, you see, many students, you see this question that is given to you here, especially brass and bronze, they set them on a yearly basis in Jamb. Now, if they are to set question for you under this in Jamb, you see, if they set it, if they are giving you brass this year, next year they might try to give you bronze. Now, they try to interwove it because they notice that many students does not really understand the composites of brass. Now, as we know that brass and bronze, they are both alloys of copper. Both of them are alloys of copper, but what do they contain? Take a look at this. Brass contain copper and zinc. Brass is an alloy of what? Copper, which contain copper and zinc. Now, they might want to twist your brain that which of them is what? Much. In brass, copper is more than zinc. Altogether, while bronze is an alloy of copper which contain copper and tin. So the question here, look at iron and zinc. Iron and zinc does not have any relationship that they can use to what? Merge together. Likewise, the same thing applies to lead and aluminium. They don't have any relationship in common. So the answer to this question here, that brass is an alloy of what? It's only copper and zinc. Because copper and tin look alike, that you might make mistake in what? Writing copper and tin as your answer. Let's move on to what? The next question in my slide. I have soap ladder. Soap ladder is a colloidal system in which a now you see, the first thing I need to understand is that what do you understand by soap ladder? Before you jump into any question in Jamb, please try to understand the question, then move on to the option. I can give you a tips at the end of this video on how you can what? Tackle question. Please stay to the end of the video. I'll be giving you some tips that you can use to tackle question in Jamb. Now, look at this question. The soap ladder is a colloidal system in which, you see, there are different kind of what? Colloidal system. It can be a liquid and liquid system whereby a liquid is being dispersed in a gas, or sorry, a liquid is dispersed in a liquid, or we can have a liquid and gas system whereby a liquid is dispersed in a gas. We can also have a solid and liquid mixture. But let me give you one thing. In Jamb, they are going to what? Base their question on 3. The first one is emulsion. We have erosion. Emulsion and erosion. And then the last one that is there. Okay, let me take a look at this. You see, for emulsion, it simply means the dispersion of a liquid in another liquid. Altogether, that means a liquid is dispersed in a liquid. We have what? Emulsion. Altogether, example is paint. And we can also have what? Aerosol. Aerosol simply means the dispersion of a gas in a liquid. A gas is being dispersed in a liquid. Altogether, now if a gas is dispersed in a liquid, we have what we call aerosol. While the last one is what we call sol and gel. Sol and gel is simply the dispersion of a solid in a liquid. This is an example of what? Colloidal dispersion. But in the question given to us, they said ladder is a colloidal system in which now you see ladder is a colloidal system in which a gas is being dispersed into a liquid in a liquid. A gas is dispersed in a liquid. Altogether, that ladder is that I'm talking about is just the foam. Hello, foam that you normally see when normally when you have a what a substance that will dissolve in water, like a detergent that dissolve in water. Normally, detergent is going to produce foam. That foam, are you getting what I'm saying? Is a gas. It's showing that if you notice that the foam itself will just be only at the surface of the water. It will not sink into into the water. Are we together? So it simply shows that what is colloidal dispersion. So whereby we have what gas inside a liquid. The answer to this, they kind of look alike. Liquid is dispersed in a liquid is dispersed in gas. If you watch option A and option D, they kind of look alike. Thereby, we have a liquid that is dispersed in a liquid. Sorry, gas is dispersed in a liquid, and also we have what liquid is dispersed in a gas. Now, which of them is dispersed in one another? That means, just like it said in solution, we always have a solvent and a solute. As we believe that a solvent is a substance that will dissolve a solute, while a solute is a substance that is being dissolved in a solvent. So in this case here now, which of them is what? But in colloidal dispersion, we don't have solvent, we don't have solute. I can take them as solvent. We have what? The disperse and what? The disperse, which is serving as a solute, and what? And the dispersion. Dispersion is serving as the liquid, the solvent. Altogether, hereby we have a solute is being dispersed in a solvent. So the disperse is the solute. Altogether, the dispersion is the solvent. In this case here, gas normally for soap to ladder simply means the gas will be serving as a disperse, while liquid will be serving as what dispersion. Whereby it's the one that's going to what dissolve this. But don't forget that gas will not dissolve in it. Altogether. So the question to this is what A. Option to it is A. Please don't make mistake of what liquid is dispersed in gas. Altogether. Now let's move on to the next question. This one looks somehow. It said a sample of air that has been passed through caustic soda will, hello, you see, normally there are some kind of gases that are present in air. Are we getting what I'm saying now? Now, what are the major gases that we can see in air? One of the major gas that you can see in air is carbon dioxide. It is present in air. Another gas that is present in air is nitrogen gas. We also have rare gases, or we call them noble gases. And also, carbon dioxide is also present in air. And then we have water vapor. Now, if air is what passed through caustic soda, what you're supposed to think in your brain is that all these gases are passing through caustic soda. That means carbon dioxide is going to pass there, oxygen will pass, nitrogen will pass, noble gases is going to pass, water vapor is going to pass there. But the problem here is that what? Look at the options. It said it will be free of noble gases. That means they are referring to the what? The solution. That means they said a sample of air that has been passed through caustic soda will be free of noble gases, not turn lime water milky, recurrently of glowing splins, be moisture free. Now, if you check what is here, I'm sorry, gas should be what? It's going to be moisture free. Then we have what? Moisture free. Now, if you take a look at what is there, it cannot be free of noble gases because caustic soda will not trap noble gases. Altogether, caustic soda only has the ability to trap carbon dioxide down. And if carbon dioxide is being trapped from the solution, automatically, carbon dioxide normally have a property. It's turn lime water milky. Whenever it is passed through whenever it meets something, one of the function of carbon dioxide is that what? It's turn lime water milky. Now, they are trying to tell you that what? A compound, let me say a gas that turn lime water milky will be there. Altogether. Now, here, if since caustic soda is going to trap that gas that turn lime water milky, automatically it does not turn lime water milky when it is passed through caustic soda. Now look at this. Recurrently of glowing split. This is for oxygen. Oxygen Since oxygen will pass, oxygen will not be chopped down altogether, then it will be rekindled. Another thing is that what moisture be moisture free. Moisture will be free from it altogether. That is it. Now let's go on to the next question, which is this. Now you see, these questions are all found under what nature of matter. I know that is the major point where many students hate most in chemistry. Take a look at this. The nitrogen from the liquefaction of air altogether. That means when air is being liquefied, normally air is what liquefied to turn to what liquid. They said the nitrogen from the liquefaction of air is denser than that got from nitrogen containing compound due to the fact that the former contain what? Which of the former are they referring to here? This question, they are only referring to the what? The nitrogen that is gotten from the liquefaction of air. Altogether, normally nitrogen from what air contains some gases, majorly rare gases. Altogether, now nitrogen from air will contain noble gases, while that is gotten from other containing nitrogen containing compound like nitrogen 4 oxide, ammonia. All this one is free of noble gases altogether. So the answer to this here, normally we know that oxygen is found in air, noble gas is found in air, water vapor is found in air, and carbon dioxide is found in air. But the reason for the density of that nitrogen is because of the presence of noble gases that is found in it when it liquefied. All together, all put together. Now, why will it be like that? It is found under when we get to some gases due to ideal gases and real gas behavior. We can understand what the reason why noble gas is going to what join to nitrogen when it was liquefied. All together. Now let's move on to the next question. It said when air is passed through alkaline solution of pyrogallo. Here you have different thing here. Alkaline solution of pyrogallo, lime water, and other fused calcium chloride. The gases left are, now let me give you this thing, let me analyze it for you one by one. What is the function of alkaline pyrogallo in this place here? Alkaline pyrogallo has the ability to trap oxygen. Whenever alkaline pyrogallo is passed through any solution in which oxygen is present, alkaline pyrogallo is going to trap the oxygen that is present in that solution. Note that as number one. Altogether, now, as you know that what in air we have oxygen, automatically oxygen has been removed. So oxygen will not be here because it has been trapped. Number two, lime. Lime is going to trap carbon 4 oxide from air. So if the solution is first passed through alkaline pyrogallo, oxygen will be trapped. When it is passed through lime, carbon 4 oxide will be trapped. Please take a look at all this. Now, when it's not passed through fused calcium chloride, what is the function of this calcium chloride? We know that what calcium chloride is a salt. I'm sorry, it's a salt. I want together, and all these things they are salts that absorbed moisture altogether. So when it is now passed through fused calcium chloride, moisture that is present in which is the water vapor will also be trapped. So how many gases have been trapped there? Oxygen is trapped altogether through alkaline pyrogallo. Note that alkaline pyrogallo will surely trap oxygen. The second thing is our lime water will trap carbon 4 oxide. The two gases have been removed. Fused calcium chloride is going to trap water vapor. Then what is the remaining gas that is there? As you know that we have 5 gases there. The remaining gases that will be there will not be what? Noble gases and nitrogen. Altogether, it looks somehow confusing. You grab. So the only gas that will be left here after all this reaction is noble gas and nitrogen, which is option C. Now let's move on to the next slide. The same question on diamond again. They said diamond and graphite are form of the same elements because are you guys me? They are the same elements. Because why is it that diamond and graphite are form of the same elements? Why? What do you normally use to what? Distinguish them? We know that what they said. Let's start from option D. They said are both used as lubricants. Let me make you understand something. A substance that can be used as lubricant must be a soft solid. Now, diamond is very hard in such a way that what diamond cannot be used as as a lubricant. We can only make use of diamond as an abrasive. How do you get what I'm saying now? Abrasive, something that we normally use to what? cut metal. That's what we normally use diamond for. So it cannot be used as a lubricant. Only graphite can be used as a lubricant. Number two, both form carbon dioxide on combustion. That's number option C. Don't forget earlier on, the reason why we have diamond and graphite are form of the same element because they have what? Let's say okay, both have the same density. Note that the density of diamond is more than the density of graphite. Both conduct electricity. Please take a note that only graphite can conduct electricity. Diamond does not conduct electricity. Automatically, what will you have there? I'll be having my option to be option C. Both form carbon dioxide on combustion, which is their chemical property. Don't forget I said something. Whenever they ask you the distinguishing, sorry, the differences that is found between two allotropes, you can easily differentiate between two allotropes using their chemical properties. All together, that's what they have in common. Sorry, physical property is going to differentiate them. Why their chemical property is the similarities that is found between them. They have similar chemical property. Are we together? Please, I said at the end of this thing, I'm going to be giving you some tips, like let's say like 3 tips that you can use and you're going to pass your exam. Stay to the end of this video. Please, if you have not subscribed, if you are new to my channel, please subscribe to my channel and click on the like button. If you like my video, please like my video and then comment in the comment box section below. Are we together? Now, let's move on to the next one. They said, in which of the following pair of elements do the elements exhibit allotropy? Now, I want to ask many questions. Sorry that I'm throwing the question back to you as the audience. Now, allotropy, we knew that the only allotrope that we know as a student is that we believe that what? Phosphorus is an allotrope. All together. Carbon is an allotrope. Sulfur is an allotrope. Sorry, let me come back. What do you mean by allotropes? I've been saying allotropes since, but some people might not understand what we call allotropes. Allotropes, they are elements that exhibit the same chemical property. Are you get something now? They exhibit the what? Chemical property. For example, they can be an element of the same type, like carbon. Now, what are the major allotropes that we can have? We can have allotropes of carbon. Carbon has 2 allotropes, or sorry, 3 allotropes. We can have, that is diamond, graphite, and what? And amorphous substances. Another allotrope that we can have is phosphorus. Phosphorus has 2 allotropes, which are what? Red phosphorus and then white phosphorus. All together. Another allotrope that we have, which is not included in this question, is tin. Tin has 2 allotropes, white and also what? Red tin. All together. And also sulfur. Most of you know about the sulfur. We have what? Rhombic sulfur, monoclinic sulfur. All together, these are allotropes of sulfur. Now, the one that is not known to you is an allotrope is oxygen. Oxygen also has 2 allotropes. You notice that what oxygen can have O2 and O3. O2, we normally call it dioxygen. That is your normal oxygen. Altogether, O3 is now what? Your ozone, which is what? Trioxygen. These are the 2 allotropes of oxygen, dioxygen and trioxygen. Now look at this stupid question that is given to you here. It said, in which of the following pair of elements do the element exhibit allotropy? Now note that hydrogen will never exhibit allotropy. What are they trying to ask here? They want to know which of the pair. You know, we have 2 elements here. I mean, which of them has allotropes? All together. Now, hydrogen and phosphorus. That is wrong because hydrogen is not an allotrope. Phosphorus is an allotrope. Oxygen and phosphorus, which is also wrong. And we also have what? Sulfur and oxygen. Sorry, oxygen and phosphorus is right because that is the only one that are the only pair that are allotropes. Look at the last one, sulfur and oxygen, which is what? Typically wrong. Sulfur and hydrogen, typically wrong, and carbon and hydrogen is also what? Typically wrong. All together. Now we've got to the end of this. I said I'm going to give you at the end of this class tips that you can use to answer question in Jamb. The first tip, tip number one is that read the question very well before you jump into conclusion of answering it. Many students have failed in the past just because they believe they know. Me, I'm the omni-knowers. All together. Now, they believe that they knew everything. So, because of that, they failed. Why? There are some questions that they need to take their time to understand, read, and understand the question. But no, they jump into it because I've seen this thing in past question. Don't forget that nowadays the past question have been what twisted for you. Jam does not have any question anymore. The only thing they do is that they twist the past question and restructured it for you as a question. Now, if you have seen this thing in past question, you tend to what jump into it, then you jump to fail it. All together. So in that case, there you need to study the question before you answer. Now, the number two that is there is that what any question you don't really understand very well, you don't understand the concept, leave it, skip it, and come back to it later. Don't waste much of your time in exam. Altogether, you only have 2 hours to solve, and each question shouldn't take you more than a minute to solve them. A minute is too much when you are not doing calculation. Theory should be taking you like, let's say, like 30 seconds to solve it. Altogether, that is that. Please, if you can follow this thing, you can easily what score high mark in exam. Specific 300. This is what I use that I used to score 300 plus in my what jam. Whereby in my first time I scored 82 in chemistry for the first time. Whereby I don't really know anything about chemistry, but I studied chemistry for 2 months and I scored 82 in chemistry, which is awesome in jam. So you can also do the same thing. Thank you. Thank you for watching this video. Please don't forget to subscribe to my YouTube channel. Are you going now? Don't leave. You need to what? Click on the notification bell and click on the like button to what? Like my video. Thank you. See you in the next episode. Thank you.